Hi friends, welcome to follow up. Let's look at problem 980, unique path 3. This problem is marked hard by leetcode. So here we will have a slight detour in methods. In the previous two videos on the unique path problem, what we used was actually dynamic programming. So here we want to use traversal. Here we can use depth first search, for example. So here we are given an m by n integer array called grid. So here 1 represents the starting square, 2 representing the ending square, and 0 representing empty squares we can walk over, and -1 representing obstacles that we cannot walk over. So we want to return the number of 4 directional walks from the starting square to the ending square that we walk over every non-obstacle square exactly once. So actually this condition tells us the length of the path, right? So here are three examples. In the first example, the return is 2. So in the explanation, it lists the 2 paths. And in example 2, the output is 4, and it actually lists all the 4 paths. So in the last example, so this output is 0. So there's no path that walks over every empty square exactly due to the configuration, right? So the constraints for this problem are the following. Basically, m and n are the number of rows and number of columns. They are bounded above by 20, and the total number of cells is bounded above by 20, right? And also there is exactly 1 starting cell and 1 ending cell. So this is a consistency assumption. So with that said, basically we are ready to do the coding. So for this part, because the logic of this problem is very straightforward. So basically we want to do a counting the path starting from the starting cell and ending at the ending cell without walking through the obstacles, and walk through every empty cells once and exactly once. So here the strategy would be actually very straightforward. We just use traversals. So here our plan is the following. So we are going to count to identify the source, in other words, the starting point, and the target, the ending point. And also we want to count the number of cells with obstacles. Let's call it embed, right? So then the length of the path will be the following. So the length of the path, length of a valid path would be something like this: m times n, the number of cells in the grid minus this embed. In other words, the number of obstacles. And then also we want to write a hyperfunction, or you can say utility function, to do the traversal. So as for this hyperfunction, so you can do within the this method, or you can just write another method. So here we are going to use the latter. So this is no big difference, but we want to make the idea clear. So with that said, we are ready to move forward. So first, I'm going to get the m and n, so right? So this is length of the grid, length of grid 0. So this will give us the number of rows and number of columns. So with that said, we also want to know the start, the end, and the number of obstacles. Let's initialize like this: 9, 9, and 0, right? So we want to iterate over the grid. So basically for I in range m, for g in range n, right? So basically if grid ig equals 1, so we find the starting point or the source. So we're going to set start to be ig. So here I'm going to use a tuple. And if grid ig equals 2, so we're going to set end to be ig, right? By assumption, so there's a unique cells which with start and end, or the target. So with that said, also we want to do the counting for the obstacles. So while ig equals -1, Then we're going to increment embed, that is incrementing the counting for the obstacles. So up to now, after the for loops, so we're going to get identify the starting cell, the end cell, and the number of obstacles. So next, basically, we want to do a traversal. So for this, I'm going to write a method so that we can use it or call it, or because this method is of interest in its own set, own interest. So here, let me do breadth first search or depth first search. So we call it anyway. So we can call it traversal or traverse. So here, what we accept is a grid, right? The grid and the start, end, and the target length, target path length, target length. So here, when we call this function, the target length will be this one, m times n minus the obstacles. In other words, the empty cells. So here we include the start and end, right? So with that said, let's maybe just write with some redundancy. So I'm going to copy this line, and then let's do the standard traversal. So here I'm going to initialize a stack. So here is stack and start, and currently the path is like this, right? So notice that we can do this due to the assumption that so the number of cells is bounded above by 20. So with that said, basically it's a standard while loop, while stack. So we're going to get the node and the path. So stack pop, right? So here we pop from the tail. And then let's first check if node equals the end, right? In other words, we arrive at the destination. And also we want to check the validity of the path. So the length of the path should equal to target length. So if this is the case, so we're going to yield this path. So in other words, we're going to get an iterate for this function. So otherwise, so here else, so we're going to denote this node by x and y. This is the coordinate. And then basically we want to check the neighbors in x minus 1 y, x plus 1 y, and x y minus 1 x y plus 1, right? So this is all the 4 possible neighbors. So we want to make sure this RC is inbound and not visited, right? So we want to make sure so this R is greater than or equal to 0 and less than m, and 0 less than or equal to c less than n, right? And grid RC shouldn't be -1. In other words, it cannot be an obstacle. And also we want to make sure RC not in path, right? And if this is the case, so we're going to stack append this piece of information. So here what we append is a tuple which consists 2 pieces of information. So one is the position, right? So the other is the path, so ending at this position, that is RC. So with that done, basically we finish writing the traverse function. So next, let's come back to the main function here. So what we want to do, first we want to get all the paths. So path equals self. So we're going to call traverse function. So we are going to accept this grid, and also we want to know the start, the end, and the target length, which will be m times n minus embed, right? So this will give us all the passes, so all the valid passes. We just need to return the length of this path. So here we return as an iterable, so we are making a list. Let's see. So this actually forms a solution to this problem. So before we make any comments, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. it passes all the generic cases. So here we want to comment that so there are 3 problems like unique path 1, 2, 3. But in the first 2 examples, we used dynamic programming to approach those 2 problems. But here we have a slightly detour in method. So here we used traversal. So in this problem, the way we write the traversal function is based on, because here we are using stack, we based on depth first traversal, right? So then basically we call this function and then return the counting. So here we want to notice that this problem set is actually not very large. So here m times n is bounded above by 20. In other words, there are at most 20 cells, or the length of the path is at most 20, right? So with that said, basically that's about it for this specific problem. So here we present one format of solution, but based on the idea or the spirit, you can actually devise or design other formats of solutions. So with that said, basically that's about it for this video. Thank you.